through very careful design you can do it, but there's not really a plug-in mechanism for that. The most distinguishing feature with pytest is, I mean, there are actually two, is how do you do assertions and how do you handle fixtures. And that's something we're going to talk about in some detail, what is the current state of pytest art there. Also some other plugins, I'm going to mention that in more detail. So cross-project tool really just means it's a tool that is external to the project it is testing. So basically the whole plugins and everything that you have, they're kind of out of your project, but you can still do per project customizations. And then you just point via the command line, you just point to a directory or you point to a certain file that you want to test. And there's a certain auto-discovery mechanism that allows to find all the tests there by naming convention, which of course can be changed if you like to. The test discovery is, the rules for that are that everything that has a test prefix is found in the files. And then inside the Python files, everything that has a test prefix in the functions, so plain functions are fine, and test classes. And this, of course, if you can just do and work from that, becomes very easy to actually write a test, because you don't have to import something from somewhere, subclass, and so on. And that's actually, I mean, when I gave these courses to people, I usually have some people who are not that proficient in Python. And you might have in your organization also people who are not like, expert Python programmers and so on. And I found actually this is maybe a small thing, but for them it's very nice, because you don't have to explain subclassing first. Subclassing is to a non-programmer not that obvious. I mean, it's not even always obvious to a programmer. No boilerplate means that you just write a test function with that prefix, and you just do plain assertions. So there's nothing, basically no extra knowledge that the test tool requires from you. Test classes have the test prefix, and in pytest you're not forced to use test classes for grouping by setup state. We get to this when we talk about fixtures. Assert introspection. That has been, for some years, it has been a topic where people said, okay, but this is magic. How do you actually do that? And there's some truth to that. I mean, pytest goes a long way. Like, a lot of the efforts actually that went into pytest was into making this working nicely. And up until 2 years ago, there was some things that you had to consider, and yet you had to know that you don't have side effects in your assert expressions. But that's, since 2 years, it's not true anymore. You don't have to basically know anything, it just will work, no matter what side effects and so on. And when I say it will work, it means that, of course, assert expressions work. That's what you expect from your assert expressions. But it means that it can show you the intermediate values. So if these assertions actually fail, you will see what is the x. You will see what is the x here. In this kind of x and y or so, you will exactly see what are the values there for which this assertion failed. And as you can see, of course, I think unittest has something like 30 different names for assertions, like the self.assert and so on. And with pytest, you just don't need that. You just use the normal expressions, and you get nice reporting. And you can do some things where I think there's no, I mean, correct me if I'm wrong, but I think there's no way to do it in unittest, like this has atra and so on. Of course, you can program that or so, but it's not really there. And you would yet have to learn more names. I mean, you have to know all these names. You know the Python expressions already, but you still have to learn all the unittest names. So with that mechanism, you don't need that. The one exception is where you have exceptions. Because if you want to say, okay, I call this code, and it's going to raise an exception, that you cannot just, I mean, you could do a try except yourself, but that's a bit cumbersome to write in tests. So there's a helper that allows you to do things, and this is basically the version that is now advertised in the documentation. It's the old style where there was no with statement. So you can just say, okay, I know that this is going to raise a value error, and then execute me this code block. And if this code block doesn't raise, then this will turn into a failure. because it will realize that there was no exception raised or the wrong exception raised, and you get a traceback saying, okay, this didn't happen what you expect. Let me maybe just show you some example failures, because I didn't show you what the, sorry, what happened to my, here, failure demo. So, lots of failures. So this is, for example, this here is the assertion that I wrote, and this is what pytest shows. So it shows the intermediate values that were wrong. And of course, that also works if you, for example, have function calls here, and then it shows the return values, and so on and so on. So that's not really that interesting. What is interesting is it shows you when it comes to strings, for example. It goes to great length, actually. There's a lot of code trying to give you very useful information. Like if you compare strings and they only differ in one place, you will see these nice pointers here saying, okay, this is exactly what goes wrong here. And that extends if you have if you compare something like large strings with new lines and you compare x to y, then you will see a diff. So this is using difflib, showing, hey, this line is not there, the other line is there. And if you have very large data, it's going to truncate it. So it says, okay, these characters are all the same, only here is a difference. And you don't need to do anything for that. You just use your normal assert statements, and pytest at every time tries to present the information, the difference, the failure, in a way that is helpful and makes you quick to understand what is different here and then investigate from there. The same is true for multi-line things. And of course, the same is true if you go for list comparisons. So you have long lists, and at a certain index, there's a difference. Or long lists, then it just abbreviates. And you can usually get the long representation by passing minus verbis verbis, and then you get everything in case you want to see more context. The same is true, of course, for dictionary comparisons, for set comparisons. So it tells you what are extra items there, and so on. And it goes on. And on top of that, you can actually even, if you have user objects that you compare, for example, my user object equals another user object, then you can even have a little extension in your project that shows some extra information. Like, is this object having a live database connection? Some extra information you always want to see when these objects appear in your traceback. Okay. So there's not really much that you need to know except that you can basically use arbitrary data structures in your expression. And whenever there's something like a case where you think, oh, but this could be actually presented more nicely, then you can find an issue about that. And at some point, this can be improved to have better reporting. This is how this evolved. It's the result of basically 1 year of making this nicer and nicer in the presentation. Okay, so that's that. That's easy. Some options that you have in pytest, also in other test runners, is you have, if you run tests and you use print statements or have some logging or something like this, it's going to be captured by each test that is run. So if a test fails, you're only going to see the captured output during that test run. With -s, you can say, please don't do that. I want to see everything just as it goes. With -x, you can say, please exit instantly if there's a failure. With -k, you can say, I know a subpart of the function name. So I just say pytest -k, database, and then every test that has a database name in it will be run, and so on. So there's lots of options. If you don't like the traceback generation that pytest does, because it provides a bit more output, as you have seen, then you can also switch to native traceback generation, like the Python native one. There's also a short version, and there's some work to be published soon on having even nicer tracebacks. --pdb gets you into a Python debugger on a failure. Okay, but the real power actually of pytest, this is kind of, if you knew pytest, kind of old news. Maybe you don't know the newest assertion reporting, but this is not really the new thing. And maybe I need to ask, I mean, how many of you know PyTest already? Okay, that's about half. And how many of you have used fixtures from that? Okay, not so many. That's good. And I guess most of you know unittest, right? Unittest is something that you all use, okay. Okay, dependency injection, huge topic in testing. You can always find this if you read testing books. They always talk about this concept, also in the Java world very much and so on. So what is that? Without looking there, do you know about dependency injection? Who knows about that? Okay. So I think it's worthwhile to clarify what this actually means. Dependency injection means that if you look at the top mail sender example, that is what can be called implicit dependency creation, or an implicit dependency. That means you instantiate the class, and somewhere inside there's a dependency to a different component, in this case the SMTP library from the standard library, so that what the mail sender actually does is at some point it makes a mail connection and sends mail out in your application, and it creates this dependency on the class responsible for that implicitly. In the second case, it's an injected dependency. The dependency is injected into the class so that the caller actually has to construct the class which is going to be used, and it passes it in. And this is used for testing because in the first case, if you want to test the functionality, you actually have to patch, you have to monkey patch SMTP. So the creation of this dependency on the mail service, you cannot influence it. It's inside the code block of the init. You cannot, change it. So you have to monkey patch before you run a test that does it, so that you don't require an actual SMTP server somewhere. And with dependency injection, you can directly send in an object, dependency inject this object into the other class. And that doesn't need to be a full SMTP service, but it can just have enough methods, the methods that this class uses, in order to simulate what the mail server is doing. So that's dependency injection. And PyTest actually works with this mechanism on several levels. So a test fixture in PyTest is responsible for setting up objects before you run your tests. And it provides a test function or multiple test functions with pre-configured objects from your application. And this is very important to have this factored into some place so that you can reuse this kind of setup for multiple tests, like your database creation with some initialized tables and so on. And in PyTest, this is actually done by having test functions accept argument values that basically are the fixtures that this test needs. That looks like this. The test function that you see here, it requires a DB object. And that's a fixture. And when PyTest actually wants to execute this, it looks, is there a function registered that can provide me this fixture? And that is something that since PyTest version 2.3, you do like here, like this above. You basically just use the decorator and say, this is the function for the DB resource, and it basically somehow creates the database. And then suddenly in all your test functions, in that module in this case, but you can also make it project-wide, you can just use the DB argument and get your database. Just to make sure that everybody understands this, so each fixture has a name. And the test functions get fixtures injected by looking up a fixture function that satisfies that name. And the fixture functions just return the fixture value. So that's the basic description of this mechanism. That's not all that you can do. There's lots of things that you can do with fixtures on top of that. For example, if you want to say that this fixture is actually something that only needs to be created once per module, then you just write with the decorator, just say, okay, the scope here of this, the caching scope of this fixture is module. And I simulated like a heavy setup of the database by the time sleep 2. And so I have 2 tests. Oh, the answer here is wrong. I'm sorry. That should be DB, of course. That's a DB here. And both tests use the DB fixture, but they will reuse exactly the same instance. Because PyTest sees, okay, you want to use that, but it's cached on a per module basis. So once it's created, it's just going to be used again. No? So by that, you gain that just by modifying your fixture function, your test functions don't need to change. They don't need to know, because at some point you discover, I don't really need a new database every test function. It's fine to just have it per module. You just change your fixture function, and you're done. Your tests don't need to, no other source code needs to be changed. If you compare that to unittest, and of course PyTest also has all these old methods, because PyTest actually introduced them, and then they were taken to unittest. That is like setup function, setup class, setup module, and so on. Then you are encoding the caching scope into the source code of the test. And you're doing this encoding of the caching scope basically everywhere in all of your test files. You say, I do this at setup class level. You know? If at some point you say, no, I actually want to have this on a session scope, then you have to change lots of code everywhere, because your caching is basically built, hard-coded into your source code. And that's something where PyTest tried to improve on this concept by basically focusing on doing everything with the fixture functions and letting the tests not have to know about this. Parametrizing. If you say, I have 2 different backends, then I have a Postgres backend, I have a MySQL backend. Then you can just modify your fixture function again. You can say, okay, there's 2 parameters, and I have, if anything uses the DB fixture, I want that test to execute twice. Once with the database instance of Postgres, and one with the database instance of MySQL. And no changes needed to your tests, usually. You can just do this on the fixture instance level. You can also parameterize tests directly. Oh, that seems to be a different screen format. So what happens here is that you, let me just, okay. What happens here is that you basically say with this special decorator pytest mark parameterize that this test function gets an argument, in this case arg1, and I say arg1 actually takes successively different parameters, 2 and 4 and so on, 2 and 4 and 7 I think in this case. So this function is going to be run as many times with these arguments, like 2 or 3 times depending on the number of arguments here. And you can of course combine this with other fixtures. So if you have your parameterized DB fixture, for example, then you can also list this like DB, arg1, and your whole tests will basically run the whole combinations of these possibilities. The reason some people use this very much, especially if you have algorithms that, like parsers, for example, they get certain strings and they have a certain AST representation they should produce, or things like this. You basically have a large table, like this is my input, this is my output, this is my input, this is my output. And the test function is very simple. It just takes the input, sends it to some parsing function, and then compares it against the expected output. And you basically just have a data-driven input-output test. One very important feature here is that this goes further in the sense that fixtures, when you have like a database, for example, you might have some special application-specific initialization that you want to do on top. So the same thing that when you actually say, in my test function, I want to use the database fixture, the DB fixture, you can now have another fixture that is db_app, has some initialized tables with like default users, whatever. And you can build this fixture by using the already existing fixture. So you have a database, and then you say, I have a higher level fixture that actually does some more things on top. It takes that other, does some things, and then just returns the DB object. So you can compose your fixtures easily. And actually, if you have larger applications, then having several, like you have like low-level fixtures and then like higher-level fixtures up to maybe your application fixture that takes lots of things. You always reuse the existing fixtures doing that. Classes can use fixtures as well, and there's one mechanism that allows you to not list all the fixtures in your methods. So you can just say, okay, this class here uses the cleandir fixture. And the cleandir fixture basically creates a temporary directory and changes into that temporary directory. And then maybe it puts a default configuration file there or not. It's like a clean thing. So any test actually will have this environment as a fixture, like a clean directory where nothing is in there. And you don't need to list it because you just work with that assumption. I'm kind of like my current working directory is empty, or it can be like your application base layout or something like this. And you can tell pytest with the use fixtures decorator that every method here wants to have this kind of default environment. Autouse fixtures are also interesting. They are a bit like the setup methods in unittest, but they also work, for example, on the session scope. Conftest is the file where you can actually put things that should be used for many modules. Like you can put things in one test module, then it's only visible to the test module. If you put them to the conftest file, then they're visible to the whole directory, to everything in there. So usually projects have one conftest file where they define all the fixtures basically that the tests use. And you might want to say, okay, before any test runs, I need to do like a big initialization of some kind of environment things. And for that, it's useful to say it's an Autouse fixture. That means there doesn't need to be an explicit reference from a test function or a use fixtures decorator. You can just use Autouse at the fixture definition place. And then this is going to be activated in any case. It's going to be used for your whole test suite. And saying it's a scope session, it's going to be executed exactly once, usually. And so before any test executes, this is going to happen. One example for extensibility. If you have a fixture where you want to influence the actual test run by a command line parameter, you can also write in your conftest file a so-called pytest hook, which is this pytest add option that allows you to add a command line option. And then the fixture takes this special request object. It's a test request object, and it goes to the config option object that contains the myop value that was defined up there. Right? So this fixture just returns the option value. Usually you just do something with the option value. Here it just returns it. And that means that you now have the myopt option here and can just, with some parameter, and that will configure your fixture for that particular test run. Of course, you can also read things from an ini file or whatever. So that was a quick ride. It's usually the first day of my testing course with 15 exercises. So it's obviously quite quick to go through all that. What you can do with fixtures is you can inject configurable resources into your test functions. And you can manage the lifetime very nicely, like the caching scope, parametrizations. You can also run things implicitly. And it basically provides for a very modular, extensible mechanism to successively build up your testing machinery that you need for your application. So, nose, I guess many of you know. A few words about this. Nose is it was kind of a clone in terms of features in 2005. And very quickly, I think Jason Pellerin introduced plugins. So at that time, Nose was ahead of pytest in offering that. But there's many shared ideas between that. And it's also true that PyTest actually runs nose test suites usually. So it's for many nose test-based projects, you can just use PyTest as well, and then if you like, successively use features from there. Of course, the fixture things and the asserts are not supported in nose like I described here in the talk. Unittest, well, I don't really need to go into too much detail there. It's a very particular model of organizing things. It comes from JUnit, which comes from SUnit. Although that's funny because SUnit actually used assert expressions, plain. JUnit, Java didn't have that, so they used all these methods. They like these methods in Java. And then I think the Python developers thought that's the true way. And they copied that. And also, at the time, there was no way really to get good information out of failing assert expressions. And there's many things that you don't have, at least by default, in unit test. Of course, you can build your own extensions. I've seen the fixture mechanism implemented by some projects, like a subset of that, in unit test. Even before PyTest introduced this. PyTest just has a very general model of how this can be done. Yes, recently people started using PyTest with unit test and came up with statements like this. So I think there's always quite some effort to keep things to allow PyTest to run plain unit test suites and also plain nose test suites. It's not the main effort because there's so many other features that are there, but usually bug reports, if some behavior is not quite right in terms of supporting nose or unit test, it's going to be fixed. That happened in the last 1.5 years because people are interested to do that, and I think it's going to continue. So if you ever encounter issues there and you want to make sure things work, then you can just do that. Plugins. Tons of plugins by now. I usually have my test run. I'm using usually something like 10 plugins at any given time myself. The PyTest Django plugin is a relatively recent development from the last year, and Andreas Pelmer there will give a talk about this tomorrow, I think 11:15 or something. On Friday. On Friday. Oh, it has been shifted. Okay, I saw something else. Okay. Are you sure? Really double check. Anyway, he's going to give a talk about PyTest Django. So I'm not going to talk too much about that. Xdist is a very popular plugin that allows you to distribute tests, capture log, makes it nice to show your logging. If you use the logging subsystem, you will see very nice output from seeing your log files. Timeout is also from a guy who's here at EuroPython, Flores. He's not here, right? He introduced a way to have timeouts so that you can say, by default, I don't want any of my tests to last longer than 10 seconds. You can modify this on the per test level or per class level or things like this, or from an ini variable and so on. Coverage, of course, you just install that. I'm going to show that. Insta-fail, I like both the name and the functionality. Insta-fail means not that your tests just fail. It means that when your test run goes on and the test run fails, it has a failure somewhere in between, then usually PyTest reports all the failures combined at the end. With insta-fail, you see them while the tests are running. So it's going, and then you get nice reporting in between. Oh, here's like the traceback, but the testing continues. So you can also look at what's going on already and see it while the things go. Twisted allows to run many of tests written against Twisted. And people have successfully used PyTest Twisted, PyTest Django, and the nose support, and I think even fixtures to have a test suite that uses all of these things and have one test runner. Use PyTest to actually run all of these different environments. where they usually had to use 2 or 3, like trial for the twisted tests and nose for some other tests and so on, and now they can just use these plugins for that. pep8 actually allows you to configure in a somewhat nice way what kind of warnings you want to treat as errors. So you can have a test run that automatically shows you, basically checks your coding style, and you can configure that quite nicely. Quick check comes from Haskell. It means that you can very easily tell via a decorator if you want to have random parameters passed into your test function. So you say, I want to have an integer in the range of this and that, or I want to have a string of length so and so of these characters, or just the full ASCII set, or something like that. And this gets actually just, via a random randomizing, gets actually passed into your test function, and you can just use these random values. And BDD. Relatively recently, somebody from PayLogic, where they're also using lots of pytest, came up with a very nice module for behavior-driven testing. And it's a very nice integration of behavior-driven testing, if you like that, with the pytest fixture mechanism. There's many more. Just look on it. Look at the plugins list that you get via PyP. If you just say pytest, then you will see lots of plugins there. Coverage means, how does the plugin mechanism work? You just say pip install, and in this case, you just say pytest -- coverage equals path to my package, and then you will see the coverage for that particular files on that directory for your tests. Or you can get a HTML report. Distribution plugin, you just install it, and you say -n4. That means it distributes your tests to 4 sub-processes and runs them in parallel. --boxed, that's actually Unix only, but some people testing C++ libraries use this. It runs each test in a sub-process, so that if the test crashes because the C library crashes, your test run still continues, and you get basically a segmentation fault for that. That's usually something that you do when you discover that your test run just breaks because you get a segmentation fault. Then you repeat the test run with --boxed to actually, get a fuller picture of what is breaking and what is just, one test causing trouble. An upcoming pytest 2.4 feature, and I would like to actually ask you, I'm doing this before we introduce this, actually. Andreas Palmer is a big fan of this feature, and some others are as well. I'm still slightly skeptical. So I ask you, from what you have gathered now from the talk, what does this do? Like, this is my test function. I use this this fixture. And what does this fixture function now, what does it mean? Any ideas? Yes?
I was preparing a question for the end, like how do you do teardown and cleanup of a fixture?
Yes.
So I guess this was the answer.
This is an answer in 2.4. I mean, the previous mechanism, I didn't actually mention that. It's a good point.
There is.
Yeah, of course. There's a mechanism already. Yes, for some reason the slide is not in there. I'm actually wondering why. But yes, there's a mechanism, request.addFinalizer, in a fixture function, how you can register from the fixture function a finalizer. So that's already there. That's already there. But this is kind of like a new way to do it. And okay, so how many of you think that you understand what this means? Okay, great. And I guess all of you that raised your hands, you know what context managers are, right? Okay. And context lib and things like this. Not too many people actually do. And the thing is here that, I mean, what happens, this is the same syntax that you find in the standard library on context lib. Does the minus mean? No, it's still 5 minutes to go, right? Yes. The context manager means that everything before the yield is actually the enter phase of the with statement that you usually have, context manager. The yield is actually the value that is provided. And what comes afterward is basically the exit phase of the context manager. That kind of like, if you accept this and you accept the yield statement, it's kind of a nice linear way to actually write your setup then provide the value, and then do the teardown. Yes, so this is probably going to be introduced like this. What it means is, if you have existing context managers from a library, from your application, then you can write fixture functions like this, right? You can just say, this is my application fixture. It uses a DB fixture, and then I use some kind of context manager I have, and I provide my application value within that transaction, and that's all you need. You can just reuse the. If you consider if you have to split this up over setup and teardown functions, it's going to become very awkward to actually write this. Here you can just write it like this. So this actually works currently on pytest trunk. We are still arguing about some details on how to make it final. It's going to be there in one way or another. It's basically just the fiction. The question is just how to declare it. So one thing that I like to do also in the courses is that I think coming up with your testing machinery for an application requires basically similar thought than the application itself. Like, how do I configure my resources so I don't have to write totally redundant code everywhere, so that I can easily refactor things. So if the instantiation of my application changes, I have exactly one place I need to go to in my fixtures, and everything works, right? I'm not spreading my instantiations of all kinds of high-level objects like all across the test suite in all kinds of setup methods or something like this. So you actually take some thought to have a good, clean, modular design on this depends on this. For the application, I need a database, I need a mail sender class, I need this. But I can also have a mail sender fixture that just does the mail sending thing, and I have tests just doing that, But it builds up basically, just like your real system. And you kind of like have, especially for functional tests, this is a very nice way to go about it. And one thing that is very easy to do is having nice reporting on failures. You can add to your test run, you can add lots of extra information that is useful for your particular environment. Okay, so that's basically it. Some nice feedback from people on recent developments in PyTest. Always, of course, for an open source project, very nice to see people being very happy about things. And thank you very much.
Question time.
Oh, you had a...
I have a couple of questions. The first one is, I saw in your presentation that you allow a fixture to be used in more than a test. Is this a good way of testing? I mean that there is an interrelation between the two tests, and they can change the fixture to each other.
Mm-hmm. Yes, good question. Like usually, you want to have total isolation. And isolation in the sense that that each test can, it doesn't matter, the order of tests doesn't matter because they basically work from a clean environment. But it's basic, I mean, for development often that's very unnerving because it might take very long, to have every test, have all the setup done for that. And for that you can, what you can do in PyTest is that you can say, okay, during development, I actually have caching scopes, sometimes of session, of module, whatever you like, And then in my continuous integration run, I didn't show the example, but in the continuous integration run, you can have a command line option that says, no, here I'm actually going to have a run that takes longer because the application is going to be recreated for every test function, So you can do this basically from the command line. And so you can change it between development time and continuous integration time, kind of like taking the best of both approaches. Okay.
Second one is about a migration to PyTest. Is there any migration from unit test or nose to
yes.
yeah? Is there any documentation about it or some scripts to be able to do this?
Yes, I mean there's only one thing. I mean there's not a guide or something like this because yeah, not because. I mean it's not there. The one thing is what usually works, and many people have done, is they just do it incrementally. So they don't port all of their test suite. They just start using pytest as the test runner, and also in continuous integration, and then they can actually start using features. And whenever they actually touch a certain test module, they say, "Oh, but this can be done much easier," and rewrite it locally, basically, just in that test module. And so you incrementally get somewhere else. And in terms of tools, there is something called pycommand, like this, right? And this has an old conversion script, convert unittest, py.convert unittest. And if you pass in the typical unittest test case, and with like self.assert and so on, it rewrites all of these assert names, like assert equals, assert not equals, assert whatnot, into normal plain assert expressions. That's the main effort. But that's really the only thing that it does. And I'm not sure how completely up to date it does with all the methods, but this could be done further, I think.
But like the nose test, it will run the normal unit tests if you
yes,
run
pytest as well. Yeah.
So you don't have to.
No, you don't have to convert all this, but if you at some point decide actually the assert expressions are much easier to read, And also, I mean, if you look at actual, I don't want to talk too bad about unit tests, but if you look at actual code, people actually also often do this. They actually say has attra x, y. Right? And this, in the end, doesn't give you much information anymore. If that fails, then assert true. I think it's like this. I've seen this a lot, because some things you cannot just easily express, or you don't remember the name anymore, how this is done, or you need to run on Python 2.6. They didn't have these methods, and and all these kinds of reasons. You just write something like this, and then you don't get any kind of reporting except it fails. And then you actually might decide, okay, let's just convert this, and if you just use the conversion script, this will just make that. And then suddenly you get nice reporting. So it's actually an improvement over existing. But sure, I mean, you can just still use you can use pytest first to just run your test suite, and then, at some point migrate file by file or whatever suits you.
Oh, hello, I have a question. From Lazy Guy, do you have integration with the XUnit reporting? Because I'm lazy. XUnit, it's used by Jenkins, the Java stuff.
Oh yes, of course. Yeah. Yes, I mean, I wasn't very complete in terms of features, but if you look at pytest minus, oops, let me just, it's probably not so easy. Is that easy enough to read still? So, yes.
Okay.
Right. JUnit XML, there's lots of different options. And I think the pytest documentation also has a PDF, kind of like 100 pages or something like this. And it explains many of these things. And there's on pytest.org, oops, sorry. On pytest.org, there's an example section, if I get there. There's an example section that you can navigate on the right side that has lots of different examples for Jenkins and, lots of things. Yeah.
The second question, I'm using cleanup methods in tests because I'm lazy. Do you have a solution for this?
Yes, sure.
Cleanup for
I have to admit that I somehow seemed to have messed up the slides, because there was a slide on this, I'm sure. I seem to have grabbed the wrong previous slide set. So yes, if you have, I'm just going to type it very quickly. If I have a fixture like this, then I can just say request add finalizer. some function, and this function can say finalizing, you know. And then I have a test function that uses the fixture and says test called, and here I say fixture setup, and then if I run that, it's like this: fixture setup, test called, finalizing. So that's very much at the top of the documentation. I'm sorry I missed that slide here somehow. And of course, if you do this and you have, for example, if you do this like this, and then you say, oh, just use a session scope, you know, then, and you run this again, then the fixture setup, test called, fixture teardown, right? That's what you would expect. I mean, it's, if you change the scope, it just means that the setup and the teardown, I mean, the cleanup is called accordingly. This completely avoids, if you use this kind of mechanism, it completely avoids the question of partial setups and partial teardowns. You know, in unittest, there was big discussions about, I run the setup function fails, then should the teardown function run or not? Because partially it has done something already, and so on. And because pytest splits this into fixtures anyway, any fixture that actually sets up something, like creates a value here, right? It will just say, just do it like this, you know. So it's exactly at the point where I created, and now I know how to finalize it. I just add it. And that's the equivalent you have in unittest is called add cleanup, but that only works on the per function scope. So if you want to use that on the class or module level, it doesn't work, you know. So this is independent of that. It works on all levels, at session level or whatever, and makes it much easier.
And for everybody who uses nose, I pushed Matcher pull the Whoosh author. He also used nose. I said, well, we could just use py.test, and we just switched to it, and it just worked. So it was no issue at all.
Yes.
Yeah, this looks very impressive. I'm thinking to convert some tests to it. And I'm wondering, like, this is something that I've been doing mostly by myself, like some mocks and stub objects for tests. Is there some support for that in pytests or maybe in plugins?
Yes. There is something, I mean, the basic form of mocking, I mean, of course you can use Michael Ford's nice mock library, right? That's, or Kuma's, I think stub it's called, or so on. pytest itself has a built-in, there are some built-in fixtures, like a temporary directory and things like this, and there's one that's called monkey patch, right? And the, that basically works like, I mean, what you basically do is you just say, oh, I just accept monkey patch, and then I say monkey patch, monkey patch, set attra os.path, apps path, whatever, you know, so it returns so, like this. So I just say, patch me out that function on that level from the fixture, and when I do this, then os.path, apps path from whatever is going to give me this. Right? Just. What was not closed? This. I'm sorry. Yes, I should have even seen that. Anything else? Real life. Oh, it doesn't work at that scope. Yes, that's true. So we just use functions. So sorry. Like this. So that what it does actually, the monkey patch is really, it is another fixture that when you use the set attra on something, registers a finalizer, so when the fixture ends, it's going to clean it up again. So in that sense, if your fixture actually requires something to be patched out, you can do that. I recently saw, for example, there's a fixture from somebody in a plugin on PyP that tries to mock out all network access. So it, basically by using that fixture or activating it on a session scope for your tests or whatever scope you want, it basically prevents your tests from accidentally depending on network. Because all the HTTP stuff and everything that is just patched out to none. And whenever you actually end up there, then it's just an error. you know. So there's.
So what kind of scopes exist for fixtures? I mean, it's a string, so can you just throw in anything, or?
Currently, there's function, class, module, session. And in the future, there's going to be probably something like test run. That's the idea currently. Because if you have a distributed test run, like across multiple processes, each of the processes is treated as its own session. And often there are sometimes resources that you don't want to be replicated in that setting. So the idea is there to say there's an even higher scope, which if you have a single process run, it's going to be the same as session. So session test run are the same. But if you distribute it across multiple test processes, then there's only going to be one. And PyTest is going to care that there's only going to be one database, for example, that is actually started as an external process, for example, right?
I have not a question, but just a proposition. And first, I want to say thank you for PyTest, because I don't think there is analog of PyTest, and it can compete with it. So it's like the standard now. And second is I'm seeing a lot of issues on Bitbucket for now, and I understand you are eager to include more new features, more nice things, but how about to concentrate on polishing existing stuff? And also we have 2 days of sprinting. So
yes.
What about having some little sprint?
Yes.
And I would like if someone will join. At least I will be.
Yes. Yeah, it's good that you mentioned that. I mean, on Saturday morning, we're going to sit together and fix some PyTest things. Most, except for 1 or 2 of the current bugs reported, I would say are not that critical. I mean, there's very few people being hit by bugs. I think the ordering bug of conf tests, if you have multiple conf test levels or something like this, but don't do that, you know. Anyway. Not many people do. I mean, my user recommendation is don't make it too complicated. I mean, usually one conf test file where you have your global fixtures and then some extra fixtures that's enough. You are advanced. I mean, you and your company are very advanced users of this. And this is an issue that maybe we can finalize the fix. And actually, Flores is the one who has the pull request. So we can look at that, right? But I agree. I mean, some kind of bug fixing day would be great. And maybe regular each month or something like this. But I also think there's not really, despite the number, there's not really that many where I have the feeling many people are suffering. I need to hear more suffering reports to... That's how it works. Or some bribery, you know. Bribery also works.
One question.
Yes, there was somebody there. Sorry.
Well, I actually have 2, but I can start with one first. With the fixtures definitions, I really like Microfort's patch library. Can I actually, or the mock library, can I actually use how fragile is the fixture definitions? Can
you use what exactly?
I like the Microfort's mock library, and I wonder how fragile the fixtures are. Can I just add patch decorators on fixtures instead?
Like this, right?
Yeah, but on fixtures, so that I would have a fixture that would do the same patching every time, or do I need to do the manual dance?
Yes. Cool. It should be quite possible. I mean, it's really just Python functions. If you have in your fixture, you decide to use the mock library and do things and patch out things with the mock library, fine.
Okay,
that should be just great. I mean,
another quick question: the assert function, is it predefined what you can run there, or can you just throw, or not like the assert syntax? Can you just throw anything there, or
anything?
No,
anything.
Nice. I wonder why I still use nose.
Yes. You can throw everything, yes. The code was mainly done, I worked together with Benjamin Peterson. He was the release manager for part of the Python 3 series, and he's very intimate with the AST module. And there's, over the history in PyTest, there's 3 generations of doing assert expressions, And the latest one is really good. I mean, we finally, I think, solved the problem. So you can just use asserts and should not need to worry at all.
At our project, we still have a little problem with upgrading from 2.2, I think, to 2.3. Is there another bigger step from 2.3 to 2.4?
No. I mean, we try very hard to have no upgrading pain, basically. And so there's a very strong focus on backward compatibility. The approach that PyTest, I mean, I would like to know what exactly the problem is in 2.2, 2.3. Not now, maybe, but let's look into that. But usually we try to avoid any issues there. And if you look at some of the plugins that were published 1.5 years ago, and PyTest usually sees a release every couple of months, like 2-3 months or so. And all of these plugins continue to function, despite new things being added and so on. And that's by design. I mean, we try to keep it this way. And you can imagine it's not so easy because the documentation has all the nice, new, shiny features, how you do things. But all the things that were documented 3 years ago, they also work. They just cease to be documented to a certain level. So it gives you some kind of incentive to, but it's not going to break. I mean, there's very, very few things since the last 3 or 4 years that broke in terms of. And I think that's a special requirement for testing tools. It's just so much sucks if you upgrade your testing tool and things starts breaking, right? And I understand that. So, and basically we try from PyTest development to avoid this problem as much as we can.
Okay. Any more questions? I think everybody wants a coffee.
Yes.
Okay. Thank you very much.
Thank you.
I'd like to remind you that the poster session will be held in the coffee break area.
problem.
Did you like it?
Yeah. Yes.
Can I use your tie?
Yeah. It's turned on, so I'm trying not to.
Yeah, no problem. I was just fake pocket.
Okay. Okay,
this
on.
one, have you got any
belt? See.
No, or a pocket in your trousers, whatever. Why?
Testing. Can you hear me? Oops.
Higher.
Somebody left their phone up the front window.
Could you please bring it to the front desk or give it to another yellow shirt? Thank you. Try again.
Testing. Hello? Python is awesome. Okay.
I think it's hard. Okay. Very well. Just checking the camera.
Hey. How do I turn this off?
Okay. Good evening, everybody. We hope you have enjoyed your EuroPython day so far. So, remember, no. Well, we've got a couple of minutes, I will just know. Okay, it's great. Tonight we have got the Google Code Jam. You should register on the EuroPython website if you want to join. And always remember, after the talk, you can vote for the talk on Guidebook, your mobile application, or on the website. So, now, let's welcome Daniel, who has come from the US, just to show us how hard it is to think about Python. Thank you.
Hi, can you hear me okay? Okay, so hi, I'm Danny, or Daniel. Danny is the informative version of my name. I know it's been a long day, and there's festivities that are going to be starting, so I'm going to try not to take up too much of your time. And I'm also going to try to follow in the footsteps of awesome people who've come before me, Armin, Martin, Paul. We'll see what I can do. So yeah, I'm in Italy, which is awesome for an American. It means I'm winning at something. So this is me. You can find me on GitHub or Twitter or pretty much any place. I'm known as PyDanny. I also work as a principal at a company called Cartwheel Web Development. I'm a principal there, and we do Python and Django consulting. Excuse me. I'm a little bit nervous here. Well, one of the things that I did this year is I published a book, or I co-wrote a book on Django. It's a best practices book. It's one of the 2 modern books about Django, which is awesome. And I co-wrote it with Audrey Roy, who's right here. She's my fiance, who I met at PyCon US 2010. And so PyCon is awesome. And I just want to point out something. This is my commits to the book, okay? Yeah, well, there's a lot. The book is over 300 pages. There's a lot to it. And people come up to me and they'll say stuff like, oh, you got something wrong. Especially the whole Apache environment variables thing. I'm sorry, we use Nginx a little bit too much. Or they say, hey, I really like this book. I really appreciate it. The thing is, though, is that often people will skip Audrey, who co-wrote it. And this is her commits. She did a lot of work. I mean, and actually, these stats aren't exactly accurate because I copy-pasted stuff from an earlier version, which wasn't on GitHub. And she also did the art and illustration in addition to code and writing and tons of stuff. So don't just come up to me and say, I really liked your book, or you got something wrong in the book. Come up to Audrey. Or maybe just say the nice things to her and say the other things to me. Yeah. Okay, so on to the talk. This is what I want you to think of me. I do cartwheels. I've been doing them since I was a kid, and I've been doing one-handed cartwheels since I was a kid. And I get to travel the world while I'm doing cartwheels, or I find ways to afford being able to pay for it. And I do exciting things. I get to come to Florence, Italy, and eat amazing food and see that all the Italians are kind of heavy. And then I realize those are actually American tourists. So yeah, this is what I want you to think of me. I'm this cool guy. But that's what I'm really like inside. That's me. I think I was 12 or 13 in front of our Apple II, and I was teaching myself Apple Basic. And the thing is when I was that age, I got obsessed with coding, or writing Apple Basic, writing games, and all kinds of stuff like that. We've all been there, and that's how I still am today, to the chagrin of family and friends and loved ones, where I get distraction. Like they start talking about something, and I'm thinking about, okay, how do I do linked lists in Python, and make it actually perform well. So that's what this talk is about thinking hard in Python and what this means for me and maybe for you. So, and there's several parts of this. I'm going to talk about coding yourself into trouble, which we all get to do. Some controversy, and I'm going to pick on some people, but I'm going to justify myself. Exceptions, and there's going to be some pretty evil stuff here, and avoiding technical debt. All right, so let's dig in. The first one is coding yourself into trouble, which I certainly have done quite a bit. And this is where I go into super. So Raymond Hedinger is a hero of mine. He's this amazing speaker, an amazing developer. He's contributed great stuff to Python core. And he gives this talk about how super is super. And it's so elegant, especially once you get into Python 3. And it's really obvious. This is using pretty much a copy of his code, which I made sure was running Python 3. This is really obvious if you've been doing Python for a while. If you haven't been doing Python, basically I have, donut is inheriting from circle, and then inside the init, I'm calling the initialization function of circle to get the behavior there. So Python 3 makes this trivial to do. Python 2 is a bit harder, but Python in general makes it really easy. We should all use inheritance and super. Well, see, here's the problem. In the real world, that's not always the case. So the contention I'm going to make right now is that super can get us into trouble. And I'm going to pick on something now, and that's Django. And I feel like I'm qualified to pick on it because I wrote a book on it. So, in fact, I'm going to pick on class-based generic views. This is actually a contentious subject in the world of Django. There's this whole functional-based views versus class-based views discussion, and I'm actually in the class-based views preferring camp of things. I'd like to use them. I'm just going to say that right now. And the reason why is because they give us stuff like these great buzzwords here, which you can use to impress your friends and family. You just start throwing them out. What's great is when you do it with junior developers or developers who know more than you do, and you're trying to sound like you really know what you're talking about. So this is what class-based views, especially the generic views, get you. Here's the thing, though. Who here does Django, real quick? OK. Look at the screen. Don't look down at your laptop. I'll get really upset. I don't know this. I do not know the ancestor chain. I wrote a book with chapters on class-based views, and I've written a ton of blog posts. I don't know this. And I can't say any of you do, because this is it. This is the ancestor chain for the update view in Django. This is a lot of stuff, and it's not a direct line of inheritance. We're talking, diamonds and rubies and all kinds of all kinds of other crazy patterns. And this is where you get into trouble. So for example, whoops, I think I went back. Yeah, I did. OK, so here, for example, in the form method of this, which is one of the methods for the update view, I don't know which form valid method I'm calling. I'm not sure. If I have if I'm inheriting from 9 other classes, what exactly am I calling? Well, I can kind of guess that I'm safe, right? I'm not safe when I see this. And this is code I wrote. I'm inheriting from 5 other classes, so like some mix-ins and stuff like that. And I wrote this code. I wrote most of the underlying code. And one day I woke up and I looked at the code and I said, I don't know what I'm doing. I don't know which form valid am I calling? And so I wrote this handy little method, which, just loops through and grabs MRI. It's not hard. And this is the ancestor chain that I got. So that was scary. It is scary. It remains scary. So then what I did is I took my little MRO thing and I checked, let's look up the versions of this class which have form valid as one of the methods, one of the ancestors that has form valid as one of the methods. And in this case, I found that there's 5 of them. And after digging into source code, it wasn't too hard, because this is actually just going to core Django, not my code. I found that I had just one ancestor. So I was relieved. I was happy. I felt in a good spot. But the thing is I was lucky. And you can dig yourself a hole with this. This isn't just with Django. This is with any heavy class-based, multiple inheritance, crazy thing. The question is did the few lines of code that I didn't have to write because of my mix-in pattern, was that worth the anxiety of not knowing for certain how my ancestor chain worked? So there's several mitigations. There's a number of them that I can think of. One is you can always hope that you leave the project and then the person who follows you isn't an axe murderer, isn't going to come and kill you. And that's unfortunately the path that I took there. I can convert it to a functional view, right? So the people who are advocates for functional views in Django will say, oh, function-based programming is the way. You never have spaghetti code. And decorators, you should have just wrapped it up in decorators. No, it doesn't. That's not necessarily the answer. Of course, I could learn better programming patterns, or I could just call explicitly the update view.form valid pattern, bypassing super because I don't know, and I need to be explicit. And one of the things that we like to focus on in Python is explicit behaviors. So yeah, this is the sort of stuff I wake up in the morning and I'm thinking about. So I have this to do that I want to do at some point is write a magical introspector for Python that works with all kinds of things where I can kind of think at it to give me the data back, and it'll give me exactly what I want to know. I know there's a module called Jedi, I think it is, that someone just recommended to me, and I keep meaning to look at it. So, but yeah, that's something I hope to work into. But anyway, let's move on to controversy. Since I've picked on Django, I get to pick on other stuff, right? But I'm nice. I try to be nice. Okay, I'm quoting from the Zen of Python, which is special cases aren't special enough to break the rules, although practicality beats purity. And everybody knows the Zen of Python, right? Raise your hand if you know the Zen of Python. Okay. For those of you who the one or two people who aren't, we like to argue framework and design decisions over the Zen of Python, and it's kind of like our Bible, so everybody interprets things a little bit differently. So this is what I'm going to talk about, is lines 8 and 9. I think I'm going to bring up Web2Py. Remember, I've already dissed on Django, so I get to complain about Web2Py now. But not hard. I'm nice. So Web2Py has implicit behaviors, and it has its own namespace pattern. And for example, actually I want to go into something really quick. At the top, there's some UTF-8 stuff. As an American who's now been in Europe for over 2 months now, I get it now. Okay, yeah. Well, I thought I have to explain myself, but I don't. Oh, that was really nice. Okay, so this code was written by Massimo himself, and I've actually talked a little bit about this stuff with Massimo. So, like I said, this is a little bit friendly. The thing is, when you look at this code, this is from a project that he was building an e-voting system for the Python Software Foundation. Him and David Mertz worked on improving the voting in of board members and other decisions in the Python Software Foundation. I'm guessing with the new Python Software Foundation design that Van Limburg talked about yesterday morning, you'll all get to touch on this code. And this code, if it is still this version, and if it's still here on GitHub, is written by Massimo. So this isn't just like crazy stuff I wrote. This is by the framework's founder. And here, there's this response object in the Python code. And there's no import for it. It's just magically there, like a built-in. And this is what I usually call, or I normally call, namespace pollution. I don't know if that is the technically correct term. I'll probably get corrected on it later, but I like to call it namespace pollution. You've got your foreign objects in my namespace. It's wrong. And when you see stuff like this, it makes you wonder, what can you expect in any location in the software? You have no idea. And so my contention is that Web2Py breaks 3 rules in the Zen of Python. The explicit rule, in the name of ambiguity, refuse the temptation to guess, and the namespace thing that I really, really like about Python. And yeah, and it's there. Those are the lines. So with this, this is the controversy. Special cases aren't special enough to break the rules, right? Well, Web2Py will contend that they've got a good reason for this, that they're breaking, that they know what the rules are, and that they're breaking them on purpose. So this is how I interpret things with Web2Py. By having the request object and a number of common HTML objects that you need in views and various other views and models and other modules, it's easier for beginners to learn. And also the namespace is easy to learn. It is obvious. Requests. If you're dealing with an HTTP web system, you're dealing with requests and responses and HTML objects. And lastly, and after typing in from django.contrib.auth import get user model a couple thousand times already, I can tell you their avoidance of boilerplate makes me wonder if, well, actually no, it doesn't, but it's a good argument that maybe we're typing a little bit too much boilerplate. So with Web2Py, it's arguing for practicality in some very specific places. And there are always people who are going to have issues with Web2Py over this. And honestly, I've been one of those. I guess I've relaxed a little bit about it, actually a lot about it. And the thing is, it's okay. I mean, magic is, there are people from other languages who will look at Python and say, oh, why are you dealing with white spaces instead of curly brackets? It's not, how can you tell where things start? I don't like that pattern. Or iterators. Maybe someone has a problem with the fact that I can do for x in y, where y is some iterable object. Maybe people have an issue with that. But the thing is yeah, a little bit of magic goes a long way. That's art by Audrey. And case in point, yeah, I love the glitter. Just to let you know, yeah, there's Flask, and it's requests object. If you doubt me, go to Flask requests. If you are in a Flask function, a view, and you have import requests, and then you can just start playing with the request object in the view itself. Armin made that as a conscious decision. I really respect Armin. He's a really smart guy. And he added a little bit of magic, and the result is a really awesome tool. People love Flask. People are religiously fanatic about Flask. And I think part of it is just this little bit of magic really makes things better. By the way, with the animation, real quick side note, I'm not Paul Hildebrandt. I don't work for Disney, but so I'm trying to follow in his footsteps. So I've got some animation sprinkled in. Okay, next part of the talk, exceptions. This is where we get into evil stuff. Okay, evil stuff. In fact, it's so evil, I'm bringing out the Comic Sans font. Silent exceptions. Silent exceptions are really awful. And a few years ago, I had a project where I did something like this, and I know there's a very high-profile developer who I was working with for a little while. He's become very high-profile, and I was working with him a few years ago, and he wanted to use silent exceptions in a number of places, and I told him, you can't use it. Silent exceptions are the devil. And so he's like, well, I disagree. I'm just like, well, I'm in charge of the project, so my way or the highway. And so I happened to notice him in IRC a few minutes later asking, hey, is there anything wrong with this code? And the response to him was like, don't do that. Silent exceptions are the devil. So anyway, however, I did them recently, about a year and a half, I guess about a year ago, I was still using them in one particular place. So in Python, this is Zen of Python, the statement about it. You know, we shouldn't ever have silent exceptions unless we explicitly silence them. And I'm going to bring up a project that I maintain with Audrey called Django Packages. And what it is, it's an adjunct to the Python package index, but for Django. And it's a big catalog and index of all the Django packages that people have entered. And it hits GitHub, Bitbucket, the Python package index. And it gives you metadata so you can figure out what you want to work with. And sometimes things go wrong. You can see the list. There's APIs go down, they change. The internet sometimes flakes out, or just sometimes people move a repo, or they delete a repo, or things get taken off the Python package index. So sometimes things break and fail, so we have to analyze it. And this is what I used to do. This is what was there for a while. And you can probably see what's wrong. And here, I'll go into explicitly what I was doing wrong. So here, I don't know, when I was getting an error and then I checked the log, I would not know what the error type was. I would not be able to see a stack trace. I just get the error message. Whoops. There we go. So I just get the error message. Name B is not defined. What I really wanted was something like this. If I'm in my theoretical Python shell, I want something where if B is undefined, I get a traceback, the full traceback, and I want to get that logged. I get the error type, and I also get the error message. I want all this information. And my code, and I've been doing Python professionally since 2006, was in gross violation of the Zen of Python. And I'm sure the Python Software Foundation was going to come down on me hard, I don't think they can do that yet for your bad code, but maybe next year. So this is the process that I used to get what I wanted. And this part right here, I'm just motioning because I don't have a nice flag. That's a print. I mean, since it's a print statement, it's not colorized. But that's a traceback. And that's my error message, the little text message I was capturing before, and that's error type. And basically, this would be using a custom error handler. And the implementation was, I basically wrote this nice little custom exception. It's easy in Python. And with a nice message, a nice full traceback. Oops, let me go back one. There we go. So the nice full traceback was thanks to Richard Jones, who's off in PyCon Australia. Hey, Richard. And he gave me or maybe it was, it was Richard Jones. And now I have all errors caught, and I loop forward. Once I do that, I log it and I loop forward. I continue. So I capture the error, and then I explicitly silence it and continue going, which is, again, now I was in compliance with the Zen of Python. And I got to, I took off that issue, and I took off the fact that I'd silenced things. So that's kind of one of the things when we're working with Python, the easy route, especially with exceptions, and this is speaking to those of us who are, still getting up to speed on it. The easy thing is to do accept exception as E, and just try not to do it. Custom exceptions are really easy to learn. Use them, abuse them. It's better to abuse custom exceptions than it is not to use them at all. Okay. All right, next up, I'm going to get really scary. I'm going to, I don't know if this is picking on Guido. And so nice little side note, I can't talk to Guido van Rossum. The few times I talk to him, I just kind of gush like the fanboy I am. And it's been like that forever. I'm going to talk about decorators. I love decorators. Decorators are awesome. And if you look on the right, this is how it used to be done in Python, where you'd wrap a function in another function. And now we have this lovely syntax on the left. And when you use decorators, it's awesome. I feel at peace when I see decorators in my code. When I have a good implementation of decorators, I am in nirvana. It is awesome. And but there's nothing's ever perfect. Yeah, that's the pinch. It's and the thing is Nick Mathewson, some guy who I wish someday I want to shake his hand. Yeah, he wrote this years ago, and they used to capture these funny statements. It's great to look up these quotes. I should have made a shorter link. If you can't read this, it's you try to shoot yourself in the foot to realize there's no need since Guido thoughtfully shot you in the foot years ago. So the simplicity we have with decorators doesn't match the what the implementation requires. And this is a decorator template. Matthew Harrison, he's a good friend of mine, and he kind of guided me through really getting it down a few years ago. The way it works with decorators is when the decorator function returns a wrapper, and the wrapper function does things before and after the function is called here, and the result is returned when the wrapper is done. This is the Dutch way. There should be only one, and preferably only one obvious way to do it, although that way may not be obvious at first unless you're Dutch. So let's actually do a decorator implementation. We're going to assume that making things all caps is a memory and time-intensive function. Just bear with me. I'm going to explain this because it's really easy if you're Guido or Dutch. So you've got your data store. If this were web scale or an enterprise application or in the real world, it would be using Redis or Memcached. And there's our return function. We return the value if the arguments that are passed into the function that we're calling, if they're in the cache, then we return what's in the cache as the value, because the cache is just a dictionary. And here we set the cache. We basically call the original function of all caps that is being called right here, but from the args. And we also set it to the cache at the same time we return the value. So that's what we do. And the wonderful thing about this function is we get much, much faster capitalization or uppercasing of our strings. Because that's where your bottlenecks are going to be. Okay, so that actually isn't too hard. Yeah, this is where it gets hard. And I've had people who, after I give this talk, when I practice this talk a couple times, they'll say, well, if you just explain it as X, Y, and Z, it's really, really easy. And it just goes over my head and over the heads of the other people around them. This is hard to get this across to people. And that's because we're doing, there's recursion. And I don't know, is this technically recursion? So no, but it feels like recursion. Can we just say it's recursion? Okay, so we have a multiplier decorator. In this case, we want to decorate the all caps function with something where we can multiply it. So if I have a string that is, for example, EuroPython, I want it in all caps, and I want to say it 5 times, I can use this great multiplier function, which this is a feature that the big client wants. So here I've got my multiplier function, or the multiplier decorator sets the state for the multiplier function. Here we go. I'm going to try and do this in one breath. Okay, let's go. Ready? I can't do it in one breath. Yeah, so we've set the state, and then when the decorator function is called, the decorator function returns the wrapper function, and then the result is returned when the wrapper is done, and the wrapper function does the multiplication, and I have no idea what I'm supposed to feature there. And this is something trivially simple. Imagine if we had complex business logic attached. Okay, it's a pain point. And the thing is, I'm not done either. There's I've lost the documentation. Right? I mean, if you know decorators, even though I've lost the doc string, I guess. And there's also method decorators, class decorators, all that good stuff. Yeah, you have to use func tools if you're writing decorators a lot. So, okay, I'm done. I'm not gonna show any more decorator code because that part's hard. Yeah, so this stuff's hard. Yeah, and I'm not doing the class decorators. The thing is. Yeah, you feel this great zen when you use decorators, and unless you've got your nose into them a lot of the time, or you're David Beasley or Andrew Dawkey or Alex Gaynor or Armin Ranischer, it's not easy. It takes a little bit of mental bandwidth to get it. And it took me a while to understand this, because it's not just that they're hard. It's like, why are they in Python? Isn't everything in Python supposed to be easy and obvious? And the thing is decorators are hard to explain. And it suddenly hit one day. There might be a very good reason why this is hard. Earlier on in the talk, I talked about how class-based views can get you into trouble. What's even worse is, it is worse, or just as bad, is when you have too many nested decorators. Has anybody dealt with this one? Okay. Yeah, I see a few nods in the audience. So yeah, I've dealt with it. Just like fancy, crazy object inheritance patterns, take it easy on the decorators. Think about what you're doing or what you're giving to people, or what you're doing to yourself 6 months down the road when you have to go back to your code. The other thing you can do, of course, is use a decorator library, which is on PyPy. You can just look up, the Python package index /decorator, and it's really useful. It lets you flatten your decorators, and it makes all of this really trivial, which makes writing spaghetti code that much easier. So go for it. Okay. Let's go on to the next section. This is avoiding technical debt. So these are a couple statements I like to think about periodically, which is just getting things done at a reasonable pace. This is another 2 lines from the Zen of Python. And there are things on any project that take time. And these are them: tests and documentation. If you have to hit that critical deadline, invariably, unless the only way you can test the results of your code is through formal tests, tests go and documentation goes. And you can skip them, and there's a few risks. See, that's my Wreck-It Ralph stomping on things animation. So there's multiple coding standards, there's broken code, upgrading dependencies. This is a great one that I keep on running into on projects. Not mine, maybe a couple mine, and then of course this one, which is the really nasty one. This is where I always think the bus factor kills you, is the installation deployment of a project. So if you are not sure about what you should cut with tests, always at least make sure the test harness runs, because if it stops running now, there's a good chance no one will ever get it working again until you do version 2 or version 3, the next version. Also for documentation, installation deployment. This is where the bus factor stuff kills you. The other things are great to have, but just make sure you write that down. It's not hard. And then for test patterns, what I like to do is, instead of using the shell when I know I don't have time to write tests, that's where instead of using the shell, or the REPL, excuse me, then what I use is I use tests. I use unit tests instead of the shell to memorize things and explore things. Reject any code that drops coverage, and of course use coverage.py. So this is kind of for the easy wins in projects. I know that yesterday Martin talked about that kind of stuff. So let's get a little bit technical again, and we're going to go to part 2 of this section, which is namespaces. I mentioned I like namespaces. Who here likes namespaces? Okay, not everybody. Okay, so the thing is with namespaces, and by the way, this is being sarcastic now. I'm dipping into deep sarcasm. Import star makes you develop faster, okay? So if you need the regular expression library, just do from regex import star. Same thing works for the OS module. Twisted, let's just import all of it. Django forms. This is awesome. And there are video tutorials online which will teach you this great trick. And the reason why, there's some really good reasons why this is so powerful. And that's that it's useful. It imports everything at once. You don't have to memorize a library. You just kind of have everything in the namespace. It's wonderful. Did I mention I was being sarcastic? So what I've done is I've written this nice little function called compare, which compares two modules, two packages against each other to see if there's any collisions that might be happening. So that way, if I do from re imports regex import star or from os import star, if there's going to be any problems. And here I'm executing an action. And if I compare the OS module and the RE module from the standard library, I get two collisions on the sys object and the error object or function or whatever those things are. I don't know. I haven't even looked in it. If I compare re.sys versus os.sys, it's true. So odds are I'm not going to collide there. I'm not going to have a problem. However, on error, I've got problems. Okay? I have no idea what those problems are, but I bet someone's been hurt by that. So yeah, import star can get you into a bit of trouble. And it can kill your Python. It can break the built-ins. So I wrote this other little function called compare built-ins, which takes, let's say, the regex module or the regex library or the OS library, and it checks to see if we're going to collide with any of the Python built-ins. And let's see what happens if I compare regex against the built-ins. And here, I overwrite the compile function. And odds are it's not going to kill you. I mean, at least for the work I've done, I don't think it's going to hurt me. There's other people may have different use cases. If I import the OS module, well, I replace the open function. Yeah, this is a nasty one. This will kill everything. This will drive you batty. And so, yeah. What?
Just use file.
Just use file. Yes, you could just use file. But I use open. Tell you what, how about you? No, I'm not going to get mean on you. Can you say that to every Python developer on the planet? Okay, so yeah, this is the thing. This is the built-in function, the open built-in function. This is a doc string, and it returns a file object and accepts at least, at minimum, one mandatory argument. The OS module's version of open, it takes two arguments. So yeah, it's going to break all the things. So if you're a beginner in Python, my pro tip to you, the tip that you should do is if you see a tutorial that has import star in it, back away. If you think you really need this tutorial, contact someone you respect in the Python community. I do this all the time. Not over the import star issue. I know this one now, but I do it for other things. Contact them and say, hey, is this? What do you think of this tutorial? Make sure you get that vetted for you. So my contention is import star is not for beginners. However, there are libraries that use it a lot, and they use it internally as part of the internal API. Don't copy the internal API. It's for people who really know Python. So, all right. So I guess I need to close the talk. This person right here. This is the person I try to stay at. I always want to be thinking about Python. I don't ever want to consider myself an expert. And that's really hard to say in front of a whole bunch of people who've come to hear you speak. But I'm not the only person who does this. Armin Ronischer let us know yesterday, to stay out of your comfort zone, find stuff that's hard and challenging, and grow, get better. Like, for example, these are things I want to learn. I don't know. I get asked C questions. I don't know the answers to them, but that's not why I want to learn it. I just want to learn it because I want to grow. And if I continue to learn and get better, then I get to be that person. So, yeah, that's it. That's my talk. Stay frosty. Think about Python and other things. I want to thank all these people. A few more. And I've got one more thing. This is what I do at every talk. I need to turn this off or it'll be really loud. Hello? Okay.
So, any question? Down there, very far away.
Can you hear me? Okay, I got it turned on correctly.
I'm sure Fabio will forward.
I thought that you going to somebody else. Anyway, thanks for the talk, first of all, but you say that we should not use super, like never. But what if you would have to write your own mixed-in class? What would you use in that
So
such
what
a case?
I don't believe I actually said don't use super. I said be careful. Know what you're getting into. Maybe I should have been a little bit more explicit instead of implicit.
Yeah, sure, but it's worth to mention, but super is not bad. I mean...
No, it's not at all.
Okay, so...
Yeah. So let me restate a little bit. Super is awesome. It is really powerful. It is a great tool, just like Python. But you know, I can crash my laptop using Python. I can do it right now. All I have to do is do for x in range and just hit 1 and start doing zeros for a minute. I did that at PyCon Philippines last year in front of 30 students because I thought I was doing a generator expression instead of list comprehension. That was an awesome moment of my life. So yeah, it's a tool, and like any tool, it depends on how you use it. So if I give this talk again, I will clear that one up. Thank you. Any other questions?
More questions? Oh, down there.
In the decorator function that you showed us, you set the cache to an empty dictionary, and then you change it. Isn't like the most horrible thing that you can do in a decorator is to change the state?
Why, yes, it is. That's why.
Just wanted to clear out.
Yeah, okay. Yeah, that's an excellent point. Yeah, the cache should have been outside, or it should have been hitting an external object. When I took that code, from a cache function that I was using that was hitting an outside data store, and thank you. I'm schooled. See, I admit what I don't know.
Okay, some more questions.
So you suggested that having your user-defined exception type was better than no exception type. Where's the balance between user-defined type exceptions versus using one of Python's built-ins, like value error or type error?
Okay, so you want me to compare, or you want me to tell you when is the moment to use a custom exception or a system design, or Python-defined exception?
Yes.
Okay. Before I answer this, I want to introduce Andrew Dalkey, who on 2 days after Audrey, or the second day that I knew Audrey, he gave us a tango lesson. We consider that our first date. So thank you. All right, so he's got an excellent question. With Python, there's a whole wonderful treasure of built-in exceptions, and it behooves you to look at them and learn them and memorize them. But when there's one that doesn't apply, and you kind of have to use your own judgment, that's the moment at which you would define your own exception. And in a lot of cases, I tend to use just a plain vanilla exception base class. But other people I've seen, if I have something that's kind of touching on attributes, but isn't quite I guess what is an attribute error, I'm in front of thousands of people and I can't remember this, so please forgive me. In that case, I've seen them subclass that. So I think there's a little bit of an art. It's just like writing tests. When you first write your own custom exceptions, when you go back several months later, you look at it and say, what was I thinking? And I think it's kind of that. It's a learning experience. Does that answer your question? Okay, so he said, yes, I win. Woohoo. So he does. He's really smart. So, okay.
Anybody else?
There's one right there.
Just cut around. around the room in an incredible fashion.
Exterior needs a small room. So thank you for the presentation. And about this print E thing that you have done at the beginning, I've seen this done by a lot of beginning Python programmers.
You mean for the super, trying to figure out the ancestor?
No, this printing the exception using print. And a lot of them went on, wait, why doesn't this print a nice traceback and the name of the exception and everything?
Okay.
I kind of couldn't answer them because you would think that it would do that.
Let's see. You can make it do it. What I didn't tell you in the talk is where I'm using print, and that's just to run this little script so that way I know that I'm getting exactly the response I want before I display it to everybody here. So I use print, so it'd be nice in the REPL. Print is actually supposed to be log. I'm logging this. And what this is doing is this will be logging I'd be using, the logging library, or either in standard library or something else to register those issues, save them to a log file, or email them out, whatever I do. So,
of course, but the question is why don't the default Python exceptions do that?
Oh, are you answering that, or?
Yeah, there's a standard. Maybe the microphone helps. They can't record it.
Yeah.
There's the Traceback module in the standard library, and you can call Traceback with the exception, and it gets a configurable Traceback with a number of lines. And there's a Traceback 2 module somewhere in the internet where you even can print the local variables. So it's in the standard library.
He's saying why isn't it the default? And I think Andrew, my Tango mentor, has an answer.
Well, actually, in Python 1 and Python 2, the stack trace and the exception were different variables. So you originally had to go to syst last exec and syst.last exec value, I believe. And so entirely different variables. It wasn't until Python 3 that they were actually combined together. And so I guess Python 3 is keeping the Python 2 heritage of just showing you the type and not the entire traceback.
Yeah, and it sounds to me that, I guess with the logging library, there's an original implementation. If they change it, it'll break too many things. And this is why sometimes it's good for things not to get into standard library, so that way they can increase what functionality or change the functionality. And this is why I know some people have refused to let their packages get into core.
Anybody else? Is there somebody?
No one else?
Can't see? No? Okay. So, thank you very much again. Thank you very much. So, now there is the MongoDB cocktail, I think. If you've got your tag, you can go upstairs to the 5th floor